problem, partition equals subset sum. This problem has been categorized as a common Facebook coding interview question. So in this problem, you'll be provided an integer array and you're supposed to determine that is it possible to divide this array into two subsets which have the same sum. So for example, you're given this input array 1, 5, 11, 5. So you can now divide this array into two subarrays. So 1, 5, 5 and 11. Both of them have the same sum. So before even solving this, there's something we can think about logically. So in order to divide it into two subsets, it's only possible if the sum of all of the elements in the array is an even number. So imagine you add up all the numbers and it's an odd number, then there's no way to partition it. So before even solving it, let's just add a check for that. So first int. So if it's an odd number, return false. So we don't need to even process it any further. So given this problem, most people, I think, when they're given this problem, they try to solve it in the brute force method. So what they do is they recursively uh, traverse all of the elements inside that array, and they create all possible subsets from it, and they keep checking if the sum is equal to what the resultant sum divided by 2. So that way, if they can, from those elements, if they can somehow calculate half the sum, then the remaining elements will be equal to the other half. So that's a solution and it works, but it's extremely slow. I'm going to show you how we can do it using that recursively. So we create another helper method, boolean. Copy this. So this thing will also take in the input array, an index value, and a sum. So the index is something we'll keep incrementing every time we call the function recursively, and the sum is we're calculating what the current sum is up to that point. So here I'll just say return. Oops. I'm going to say sum by 2 because we just need to calculate if somehow using the elements half of the sum can be achieved. So whenever we are given a recursive function, we should think of two things. One is what's the base case where we end the recursion, and what's the recursive case when you keep calling it recursively. So here the base case is if the sum equal to 0. So if somehow the sum has reached 0, then we return true. Similarly, if the sum is less than 0, greater than the number of elements has reached outside of the array, we return false. So these are two base cases. Now we'll just calculate the recursive case. So the recursive case, what we do is we'll call the function recursively, but for one method, we'll include the value of the current element, and for other, we will not include it. So we'll say return can partition. First time we won't include it, so nums index plus 1 and say sum, or and this one will include the sum. So what we're going to do is subtract it every time. So yeah, let's try running the solution. And it worked. But when I try submitting it, it's going to throw a timeout exception. So yeah, so you can see, right, there is the input array is this huge values, and because it's so much processing is taking place, it's going to time out. So whenever we are doing recursion, this is what's happening. So given this input 1, 2, 3, 4, at each point we have two options. One is we don't include the value of the current element, and we keep including the value of the current element. So if the array is of size 4, you can see, right, we have to calculate it 16 times. So I've calculated the different combinations here at when it says index 0. First time we don't include the value, so we say index is incremented by 1. Here the index is we adding the value at the current index, so it's subtract by 1, so 1 4, and we keep doing this until we create the entire tree. And here this is where we terminate it, because the index 4 is greater than the value number of elements in the array. So there's one thing we can do to improve the running time, and that is memoization. So what happens is, whenever we are giving a result, we store the value either in a hash map or in an array, and later, instead of calling a method recursively, we refer to that data structure and see if we have already calculated the value before. So for example, here you can see that 3 2, and here also, even in the right tree, we can see this value 3 2. So if we have already calculated it, we don't need to go process this part any further. So this part is not required. So this helps us to cut down the running time. So here I think the tree is of small size, just 4. But if the number of values is greater, there'll be like, you realize that there's more number of calculations that we can cut down by using memoization. So let me demonstrate that. So what we can do is we can create a variable boolean, and you can notice I'm not making it. I'm making it an object, because then by default the value gets set to null. So, and then what you can say is mem equal to the number of rows will be equal to the number of rows in the array. So, and the value will be sum by 2 plus 1. And you understand why. So here, instead of calling this method recursively, we'll check index. And here we can say so. Yeah. So here, since we are storing it, hopefully it'll cut down some of the running time for the solution. Let's try submitting it. Yeah, the solution actually worked. Um, okay, so I guess it cuts down the time so much that we are able to not get the timeout error anymore. So this solution works. But if you're trying for companies such as Facebook, I think they'll ask you to try solving it using dynamic programming. So the concept of dynamic programming is that given the problem, we need to solve smaller subsets of the problem, and using that, since we're solving the smaller subproblems, the solution can be expanded to include even bigger problems, and that's actually the dynamic programming method. So whenever given a dynamic programming problem, I think the best thing to do, even during interviews, would be to actually draw a table. And in that table, we will just calculate. So given this input array 1, 2, 3, 4, 5, we need to calculate if it's possible to get a sum of 5 by using any combination of numbers inside of that array. So how do we go about it is, even during the interview, I would recommend uh, on the board, just create a table, write down the numbers, use some simple examples, and see how it can logically be done. So imagine there are no elements. So I've included 0 and 0. So 0 is the sum here. 0 means no elements are present in the input array. So even given there are no elements present in that array, is it possible to achieve the sum of 0? False. No. Since there are no elements, nothing can be combined. So first row is always be false. So I think we'll just write that. I'm having some problems with my screen, so that's hopefully you can see it. Um, so yeah, so we just say first row is entirely false. There's nothing to calculate here. Now given the element, one element in the array, is it possible to achieve a sum of 0? No. Right, false. Is it possible to achieve a sum of 1? Yes. Because the value 1 is equal to the sum we are trying to achieve. So we always say yes. Uh, is it possible to achieve a sum of 2? True. So here you cannot achieve it unless you have some other element. So since 1 is the early element inside this, we can also just say false everywhere. Now given we are that, so hopefully I'm doing a good job, but what you're trying to do is we're trying to divide this. So imagine now the arrays of just 1 and 2. Is it possible to achieve a sum of 0? No. Is it possible to achieve a sum of 1? Yes. Because we have already achieved 1 is present, so you can just say true. If it's, is it possible to achieve a sum of true? Yeah. Since the value is equal to true, you can say yes, true. And is it possible to achieve a sum of 3? Again is true. Because in the previous row, we have already determined that 1 is present. So this is a value which has a difference from 3 minus to 1. This is true, this also will be true. So 4 is false and 5 is false. So this is a kind of algorithm we can use, which is we keep processing, we create a 2D array and we try to fill out all the values inside of that array. And if this value is equal to the sum we are trying to achieve, we say true. If it is greater than the value, the current value that we have is greater than the sum that we are trying to achieve, then we cannot process it, so we just say false. And if it is less, we need to make sure that the value which is the difference, like here when we're trying to achieve 3, 2 is less than 3, but we have to check, was 1 already present in the input array? If it is present, then we say true. So I think it will make more sense when I start coding it. So first thing you do is we create a Boolean array. So the value would be nums.length plus 1. So I'm including even like an empty value. That's why I add an extra row. And the columns will also be, let me just say sum by equal to sum by 2. So sum plus 1. So this is because I'm adding an extra row and column for this. This is a no element present and for value 0. And then we'll just for int I equal to 1. So now I'm just creating 2 for loops. This to traverse all of the elements inside of the cells. For int j is equal to 0. So essentially what we are trying to fill here, we're now trying to going to fill it using this calculation. So if nums I have to say my I minus 1 because you have said the Boolean value here. So if you want to 0th index, you have to just subtract minus 1, for example. So nums I minus 1 equal to j. We just say dp. So we incremented, we set the value to true. So this is essentially what we are doing here, which is if 1 exists, we set the value to true, because then we know that we can achieve the sum that we are trying to achieve. So that's one calculation. Else if it is greater than j, so something like it's 2, for example, if it's greater, we need to check if the cell above, if that value is true or false. So here we can say dp else, and this is the condition we need to check the most. So dp I j is equal to, so here we need to check, like for example, if you have reached the value of 3. So in order to calculate 3, we have two possibilities. One is if 2 is there, we should check what the value was at 1 here, if 1 was true or not. If it was true, we return true here too. So we say or So this part should be tricky. It's j, so this is 3 minus of what the value is here, nums I minus 1. So j minus, hopefully this made sense. So here we need to make sure that if the value is less, we need to check from any of the previous value a combination is present that compensates for the value you're missing. That's what I'm doing here. Else we just set the value from the previous row. So at the end of this, we just say return tp, and the value of the column will be sum. So yeah, let's try running the solution. All right, 3 use cases have passed, and let me try submitting it. So yeah, I think the time and space, I think the time complexity should be much better than before. So yeah, just to do a recap, here we use dynamic programming, and what we do is we are creating this 2D array where we compare the actual values with the sum that we are trying to achieve, and we check different combinations to ensure the sum is equal to at least half. That way we can know that we can partition it into two subsets. So this problem, the time complexity of the solution will be O of n into m, where n is the number of elements in the input array and m is the largest value inside of that array. So I think here they've given a description saying that it can be less than equal to 100, so 100 into number of elements. So that's the time complexity. And same thing, the space complexity will be O of n into m, where n is the number of elements in the array and m is the largest value inside of that array. So yeah, let me know if anyone has an easier solution, and yeah, leave comments and I'll try reviewing them to see if it's better.